Okay, this is another question. It's, compute this integral. It's a summation of an integral. And I'm looking at it, it looks pretty difficult, actually. And I want to, again, claim that I'm taking these directly from the Stanford Math Tournament. I think it's the 2013 version. So looking at, the first thing I would recommend to do is, maybe just write down a few terms of it. And looking at it, this would equal, get my eraser, I get a better pen. This would equal 0 to pi over 3 sine 0 x dx plus, I'm doing a sum now, 0 to pi over 3 sine squared x dx. And I think you get the idea, it goes on forever. So then I start to realize, maybe I could write this as a single integration, and that would be 0 to pi over 3 sine 0 plus sine squared plus yada, yada, yada. This is actually easier for me to look at now. And I'm looking at that, it looks geometric in form. So I want to write that down. I want to write the integrand down. The integrand, I'm just going to call it S now. The integrand, well, the sine raised to the 0 power is 1 plus, that's going to be sine squared x. And again, what I'm doing is I'm writing these things down over here. That's all I'm doing. So sine to the 0, it's to the first, anything to the 0 is going to be 1. And again, I know some people might be concerned about this 0 over here. You could look at that as a limit problem. It would be equal to 1, by the way. And then you're going to get what? Sine 4 plus yada, yada, yada. All right? Let me just briefly go through. Some people can't remember the geometric sum formula or what the conditions are. But one of the conditions is that the common ratio R, which in this case over here is sine squared, has to be in between -1 and 1. Well, that's certainly true. And the reason for that, looking at it between 0 and pi over 3, the sine is a proper fraction. All right? Now we're squaring it, so I know it's above 0 and less than 1. So what I'm going to do is multiply both sides by sine squared. I get sine squared times s. That would be sine squared x plus sine 4x. This is a convergent geometric series. We're going to do a subtraction. 1 minus sine squared s. What I do there, I took this and subtracted this. Now if I do the other side, it's not that bad. What do you get there? You would get 1 minus sine squared x. All these other terms are disappearing, by the way. All right, all of them are disappearing. Whoops, I think I made a mistake there. Just noticed it. Okay, so again, it's 1 minus, nothing at that point. The reason these things are just whoops, sorry about that, I didn't mean to do that. These are just disappearing. All right, so what do you get over here? You get s equals 1 over 1 minus sine squared x, which is 1 over cosine squared x, which is secant squared x. All right, so what I just accomplished, I accomplished rewriting this thing as 0 to pi over 3 secant squared x dx. Do I know that guy's antiderivative? I do. It's tangent. So I get the tangent of x, and I'm going from 0 to pi over 3. All right, pi over 3 is, just to remind you, 180 degrees over pi. Pi's cancel, get 60 degrees. All right, got a triangle that looks like this over here. Let's see, 1, 2, root 3. And the tangent of 60 is going to be root 3. Put this over here. Minus the tangent of 0, which is 0. So what do you get? Final answer of root 3. You get my eraser out, make it neater. It's just going to be root 3. And we're done. Thank you.